Hi everyone, here we are going to continue in our series of tutorials. I'm going to part 3, covering data types, creating new variables, and group by or aggregate functions. So let's note that often when we have a variable that is coded as 1 or 0, the program R may assume that it is numeric. And to ensure that the program recognizes it as a categorical variable, we can use the s.factor function. So we just write s.factor, open parentheses, the input of the function, in this case, let's say gender variable, which is 0 or 1, and then this makes it a factor, or in other words, categorical variable. And we can also assign this into a separate variable, and we can refer to it later, so we don't have to use the full name. We can just use the shortened name of that attribute. So if we run this, you won't see much. There's no output from it, but it looks like it worked. We can do the same thing, for example, for smoking. Smoking is either 1 or 2 in this data set. We can make it a factor, and voila, it should be done. And then we can tabulate it, and we just write smoking. We don't have to write the full name of that attribute, because now we have it into a separate variable. And we just run this, and we see, okay, there are 16 cases with 1 and 85 with 2. So 16 former smokers and 85 continued or until recent smokers. Another thing we can do is create a new variable, and this is very important for many kinds of calculations we do. So creating a new variable with a condition. So suppose you have, as we do, we have a list of, we have age. Age is a numeric variable, integer, but we have some idea or some hypothesis that there is a threshold age that changes things. Maybe it's 60 or 70 or 40, and after this age, people will develop more of a particular issue, maybe COPD. So we want to calculate how much COPD people have before this age and how much after this age, or something like that. So we can create a categorical variable, kind of yes or no, 1 or 0, for this threshold age. So let's assume it is 65 years old. So what we do is we can use the if-else function. So always begin on the right here, if-else, and then the if-else function in R is the same as, at least similar structure as in the other spreadsheet software like Microsoft Excel. And there are 3 inputs. If it's not nested, if it's nested, you can put, like, you can keep going and going, but we can, if it's not nested, it's pretty simple. So the first is the condition to be tested, and we usually have a variable, and then we test if it is either less than, greater than, or equal to a particular value. So this is the first part. The second part is the result if this condition is yes, and then the third part is the result if this condition is no. So what happens here? Well, this function is going to be applied to the whole data set. Remember, the data set, there are many cases or many records. So it goes to the first one. So it checks number 1, is age greater than 65? If yes, then for this new variable, we're going to get this value here is going to be, well, this one is 77, so the value is going to be on 1. Second record, is the age greater than 65? Yes, 1. If not, 0, and so on for every record. And all the values for all those records are going to be under a new variable that I'm calling above 65. So if I run this here, and notice how this new attribute is going to be part of the COPD data frame. I run. There's no output from this one, but it looks like it worked. No error message. And if I go to the COPD data set up here, actually it's already there, above 65. But remember, this is more like a categorical variable. So we want to change this to be a factor. And actually, maybe what we can do is we can do this here. This is called nesting. We can nest the functions. So it's good to get this kind of logic. So this should work here as see the same logic here. We put the whole statement here. So for every result, we're already going to make it as factored. So this should work. And let's run it. So it's going to calculate the whole variable again. Did I run that? No. Okay, now I did. Now go to COPD. We go there. And actually, we can already see that it changed to factor. Notice how the numbers are on the left. So because the numbers are on the left, it's actually a character or a factor categorical and not a numeric. See how the numeric ones are on the right? And then the categorical ones become on the left. So now the program thinks that this is a categorical variable and not numeric, even though it's 1 and 0. And we can tabulate that. So table COPD above 65. Oops, above 65. We'll run just this line. Run. And then we see there's 0, which people 65 or less, 26, and 75 people are greater than 65. Note that I put greater than 65 and not greater or equals to, so you got to be careful with that because it can change the results. Okay, what else? Well, one big thing here that I want to talk to you about, which is the group by or pivot tables or contingency tables. So there are different names to this, but it's kind of the same thing. And in R, we use the aggregate function to calculate averages or sums or some calculations by groups. So for example, suppose, so we have here a variable COPD severity. And COPD severity could be moderate, could be very severe, could be severe, or could be mild. Now, suppose that we want to understand how much of another variable, let's say this one here, MWT1, which is walking distance. We want to see how much walking distance people with different categories of COPD severity can walk. So, for example, people who are moderate. So we have a person who is moderate here, they can walk 165, their average walking distance within a time frame. Well, another person here, moderate, also moderate COPD, but they can walk 201. We have another moderate, and they can walk 216. And another moderate, and they can walk 231. So it might be interesting to see if COPD severity is related to walking distance. And we can calculate, for example, like an average walking distance for people within different categories of COPD severity. And we can do that by the aggregate function of R, and I'll show you what it looks like. So here is, once again, let's begin on the right. It's aggregate. The function is called aggregate. And then there are several inputs to the function. The first is the measure that you want to actually calculate. And so this is going to be walking distance, MWT1 best. Then we have the tilde symbol, which is like kind of per. So this per this here, and the COPD severity is the categories. Now note that the aggregate function has to have one quantitative variable and one categorical variable, okay? And then the second input is the data. Now data is the name of the parameter, and COPD is the value. Oh, that's our data frame. So if you use a different data frame, you would put that over here. If we had data equals, COPD alternative would be here, but it's usually going to be data. So this is the actual name of the parameter. So this doesn't get changed, but COPD gets changed because that's the one we are using. And then the last one here, the third one, is the mean. So you could use other things like sum or median, but we want to get the mean, the average. Open up a separate mean function, but we don't need a separate mean function. Mean is just the parameter that this function accepts. So, and if you want to understand more, for every function that you use, you can go to the documentation. Go to the documentation so you can understand the structure of the functions and what you can put inside and how it works, what are the options, and so on. And then, as usual, we're going to get the result of this calculation, and we want to put into a separate variable so we can use it later for different things. So once again, this aggregate is going to get the average walking distance per COPD severity. And it's notice that we don't need to use the full attribute name because we are referring to the data frame right here. So if we run this, did we run it? I'm not sure. I don't think so. Let's try again. Run. Now it did run because the code appears there when it runs, but we didn't see the result. There's no output. So usually for the output, we want to see the program already recognized because you created this variable. It's already giving me the results, but the results are over here on the bottom. So what does this mean? So people on mild have a walking distance of about 458, moderate 407, then severe 368, and very severe 290. So we can see a clear pattern here. People with greater severity have different average walking distance, and it goes down as the COPD severity goes up. And in this case, it's very clear, but perhaps you want to graph this. So I'm going to show you here bonus content, how to create a bar graph for this measure. And I'm going to use the ggplot. And if you didn't install ggplot, you don't have it installed. This is a separate package you need to install. Let me see if I have it here. I'll try to run. I think I installed it, but ggplot starts getting a little bit more complicated in terms of graphing, but you can get the hang of it. There's several parts to it, and the parts are connected with the plus symbol, and the plus symbol connects different parts that visualize the data, renders the graphs in different ways. So here's the main variable that we want to graph, and this here is referring to the what's going to be on the x-axis, what's going to be on the y-axis, and this is the type of graph. So if I run this, error in ggplot, could not find function ggplot because, well, there's two steps we need to do first. One is install the package. So the function is install.packages. And then this, even though we're calling ggplot, I think the package is ggplot2. Now this one might already be installed. So if it's not installed, you need to do this first. And if it is installed, I just need to open it into my environment, ggplot2, it's right here. So even though we're calling ggplot, the actual library is called ggplot2. So I'm just going to run the library because I already installed it. And now after I pulled it in, I can run my ggplot, run, and it creates the graph here on the plots area. So it looks pretty neat. We can see the clear downward pattern. But you can note that you can use this bar graph for other kind of categorical visualizations as well. So okay, so that's it for this one. I'm going to leave you here with maybe something you can test. For example, what if you want to get average age of those people who have diabetes and average of those who do not? This is a job for one of those aggregating functions or group by, also called contingency table or pivot table. So I'm going to leave this with you as an exercise, and we'll continue next time.